Our goal in this video is to place all of these numbers on a number line. And this can be difficult at first, but if we break this down and look at positive and negative, and we think about the range of our number line, this process shouldn't be too difficult. So in terms of the range, let's just estimate. Let's find the highest and lowest whole numbers that we're encountering. It looks like 2 is the highest positive whole number. Oh, I'm wrong. Here it is. 4 is the highest positive whole number. So we know that we should go from 0 to at least 4. On the negative side, it looks like the largest negative number is around 2. So what does that mean? Well, we only need to go up to about 2 or 3 on the negative side, but we have to go up to 4 on the positive side. So when I'm building this number line, I'm going to leave a little bit more room on the positive side, just to make sure I have enough room to deal with everything. Now spacing is critical here. I'm going to estimate 1, 2, 3, 4. When I say it's critical, I mean try and be as accurate as possible. If you have graph paper, you can make the scale almost perfect. That'll really help you in a problem like this. So now on the negative side, we have negative 1, negative 2, and negative 3. So now let's plot numbers that are easy. 4 is easy. Cross it off and plot it. And then label. That's 4. Okay, what else is a nice easy problem here? Well, 4 over 2 is easy. That means 4 divided by 2, and that's just 2. So we'll label that as 4 over 2. Negative 4 over 2 is also easy. That just equals negative 2, because 4 divided by 2 multiplied by a negative 1, that's how we can see this, or negative 4 divided by 2, or any way we look at this, we get negative 2. Okay, now we're getting somewhere. Other easy ones. Well, 5 over 2 is kind of easy, but square root of 4 is super easy. That's just 2 as well, because square root of 4 is 2, and 2 times 2 is 4. So I'm going to label this as 4 over 2 and the square root of 4. Both of them are at this point. Now 5 over 2, what is that? Well, 5 over 2 means 5 divided by 2. How many times does 2 go into 5? Well, it goes into it twice with the remainder of 1. In other words, it's 2 and 1/2. So I'll plot it here. 5 over 2, just 2.5. So I converted that into a decimal. That's pretty much my technique for most of these. 2 1/4 I think of as 2.25 or 2 1/4. So here's 2. Here's 2.5. 2 1/4 should be halfway between. I'm going to put an arrow there because I'm running out of room. 2 1/4. 2.09 and 2.3 also have to be squeezed in here. Okay, so where's 2.09 going to go and where's 2.3 going to go? Well, 2.3 is above 2.24 but below 2.5. So it's going to go about right here. We're estimating. Draw an arrow because I ran out of room. That's 2.3. Cross it out. What about 2.09? Well, 2.09 is less than 2.25, right? Which is what 2 1/4 is. So it's going to go in here. Sorry, I'm running out of room there. That's my label. 2.09 is about right here. Let me erase this. Okay. Moving on, we have the square root of 5 and the square root of 2, which we'll come back to last. Negative 2.3. Well, here's negative 2, so negative 2.3 should be about here. And negative 2 1/4 is negative 2.25. It's between negative 2 and negative 2.3. About here, pretty close to negative 2.3. And now we only have 2 left, the square roots. What do we do? Well, we have to start estimating, right? To figure out exactly where these are in relation to all these points. Fortunately, square root of 2 should be easy because the square root of 2 is less than 2 and more than 1, about halfway between. You can tell because 1 times 1 is 1, it's smaller than 2, and 2 times 2 is too large, right? So square root of 2 is about there. What about the square root of 5? How do we do this? Well, 2 times 2 is 4, and that's less than 5, okay? 3 times 3, far too large, it's 9. So square root of 5 is between 4 and 3. Oh, excuse me, 2 and 3. But where? Well, let's narrow it down. Let's try 2.5 times 2.5. And to speed up this process, you can use a calculator, or if you know, it's 5.25 So 2.5 is too large. Now that we know that 2.5 times 2.5 is 5.25, we know the square root of 5 has to be less than 2.5, but bigger than 2. But we're trying to place it precisely on the number line. And we need to know, is it bigger than 2.09? Is it bigger than 2 and a fourth? And is it less than 2.3? So let's narrow it down. We'll use a calculator here. Let's try 2.3. 2.3 times 2.3. 5.29. So 2.3 is too large. So the square root of 5 has to be less, let's write this down, the square root of 5 is less than 2.3. So it's below this dot. The question is it above 2 and a fourth? Well, let's try that. 2.25 is 2 and a fourth times 2.25. 2.25 is above 5. 2.25 squared gives us a number above 5. So that means the square root of 5 is less than 2.25. Now, we can keep trying to get as precise as possible, but we just need to know if it's less than 2 and a fourth, and we know it's above 2, is it less than 2.09? So let's try that next. 2.09, well, let's try 2.1 to keep it simple. 2.1 times 2.1 is too small. Right? 2.1 squared is less than 5. So the square root of 5 has to be above 2.09, which means if I was to plot it, I would put it between 2.09 and 2 and a fourth. So I hope that helped.